I think she has a problem with the connection. Oh, okay, I'm going to present. If you have any question, you will write me maybe if you don't speak or not able to contact or communicate with me. Okay, any and say it. You can say it, connect me, but any I think has a microphone problem. I'm going to share today. I'm going to present you the Keynesian model. The application will be given to you. Are you able to see the slides?
Yes, yes, I'm able to see it.
Okay, thank you. Okay, thank you, Said and Annie. I think Kevin is not available today, and Rahel not able to attend also. I already controlled. They are registered for this class, but not able to attend. But they can then later watch this video in YouTube. As I mentioned, I have this YouTube. I have this channel for these classes. YouTube channel, and you can watch these videos after the presentation. Last week we presented the Keynesian model, the theoretical application, how it is and what it is. And today I have some numerical application. If you have any problem with this, then you may interrupt me and ask me the question. Okay. Okay, I'm going to present you the aggregate expenditure model, so-called the Keynesian cross model. Here, one sample data given, some aggregate expenditure model is given where the consumption, investment, governmental expenditure, and net export is as becomes as a independent variable, and aggregate expenditure, also called the output, is the dependent. You see the equilibrium occurs in the Keynesian model from the last week, if you remember, where the output and aggregate expenditure crossed from the 45% of the diagram. The aggregate expenditure line crosses the graph from the 45 degree, and this given algebraic equation for two lines, the point where they cross can be really calculated. Imagine an economy with the following characteristics is given. Algebra, sometimes I also not able to speak. Y is the output, the real GDP. T is the taxes. C, the consumption. The equation is given 140 plus 0.9. 0.9 is the marginal propensity of consumption, and Y minus T is the tax, so-called the disposable income after tax. And I is the investment, which is 400, and G is the governmental spending, 800, X is the export, 600, and M is the imports, where it is the 0.15% of the disposable income. And we are starting first to determine the aggregate expenditure function. In this case, it is very easily estimated because all the numbers is given there, since the C is the consumption equation, 140 plus 0.90 Y minus T, and I is 400, G is 800, and X is export 600, and M is 0.15 Y, where it is, as I mentioned to you, the percentage of the disposable income, which is 15. And then we going to use this equation for the 45-degree line is the set of points where the GDP or national income on the horizontal axis is equal to aggregate expenditure on the vertical axis. If you remember this graph, it will be very clear for you. If you don't, then I will try to show you the graph. Do you remember the graph, or do you want me to show you?
It would be better if you show us the graph.
The graph is this one. You know, this real GDP on the x-axis and the aggregate expenditure on the y-axis. And we are talking about this 45 where the y and the aggregate expenditure is becoming equal. And of course, this is not realized. And we suppose that the aggregate expenditure is always somehow where this Keynesian model is supposed to be consumption inversus governmental expenditure and net export is included, will become sometimes higher and sometimes lower than this 45-degree diagram. Therefore, we are trying to manage to find the equilibrium point and whether the potential GDP behind of this equilibrium or less than this position. We will calculate this and interpret and tell some information about the government, tell some information about the existing parameters which is affecting and changing the economical structure and model. Let's go back again. Mm, okay. As I said to you, the equation for the 45-degree lines is supposed to be aggregate expenditure is equal to output. And the third, because it is questioned in the step 2. And step 3, the next step is to solve these two equations for y or aggregate expenditure since they will be equal to each other. Substitute y for the aggregate expenditure and solve this problem, which is very easy. I think you know some mathematics. Then we put y for the aggregate expenditure and the consumption function is also all there. Then you can solve this if you're gonna subtract and change the equation from one side to another. The y will be alone, and then you will solve it easily. I think we have to insert also the tax rate, which is 0.3 y. And this produces an equation with only one variable for y. Walk through the algebra and solve for y. Then we put, as I said to you, instead of aggregate expenditure, the y, because y, since y and aggregate expenditure is supposed to be equal, it is supposed then we have the equilibrium. Then y is equal to 140 plus 0.90 in bracket y minus 0.3y. This is then the tax reduction from the disposable income plus 400 plus 800 plus 600 minus 0.5 0.15 y for the import. Then y is equal to, again, after some summarizing these given numbers, then we have 140 plus 0.90 y minus 0.27 because we are adding 0.3 and 0.15 each other. And then you have plus this 400, 800, and 600, then 1800 minus 0.15 y. Then we will then summarize it again when we are adding and reducing these numbers. Then we will have 1900, 400 plus 0.49, 48 y. Then we add this 0.48 to the other side. Then we have 0.52. You know this when you add the one parameters from left to right, it will change the sign. Either it is positive or negative. It will be negative. If it is positive, it will be negative. Therefore, we have here negative now. Then it is then y minus 0.48 y will become 0.52 y is equal to 1940. Then this will be summarized from each other. We will divide for each side. We will divide to 0.52. Then we will have y as 3730. Is it clear up to now?
Excuse me, I have a question.
Yes, please.
Where is T? I remember that in before slide, previous slide, we had also T. Y minus T. Yeah, y minus t. Where is t over there in this
T,
question?
if you look to the second line, T taxes is 0.3y, isn't it?
Oh, tell you why. Yeah.
You
Now
got
I
it?
got.
Super. Thank you, Said. Now it's fine, isn't it? You will get it. Okay, I will go to the next
Yeah,
step.
yeah, it's fine.
Say, for example, that because of changes in the relative prices of domestic and foreign goods, the marginal propensity to import falls to zero point 0.1. Now, we suppose the propensity is reduced for import and calculate, now because it was 15, calculate the equilibrium output when the marginal propensity to the import is changed to zero point 0.1. Then similar application will done. Then we summarize it and we will get when the tax rate reduced for the import, as you see, the output will becomes now higher than when you are reducing the marginal propensity to import. This is affecting and changing positively. You can interpret also the output, so-called GDP, to the higher level. Therefore, some politicians, some government people always insisting to increase the import taxes for preventing the domestic market. But while they are doing this, they are reducing their, as you see, total GDP, the output, the gross national income will become smaller. As you see, it is increased. It was 3,730, and now it is becoming, because before it was 0.50, and after reducing it to zero point 0.1, then the output becomes 4,127. Therefore, marginal propensity to import, if it is reduced, this will positively affect and increase the output in numerical numbers, in the monetary value. And when we are looking to the next step, because of surge of business confidence, investment rise to 500, calculate the equilibrium output. Now we are trying to solve this problem when the investment is supposed to be increased, how it is affecting and changing the output. Then we may say the increasing output to 400 from 500 will negatively affect and reduce the output. But as you know, investment is the future proposed realized activities and entrepreneurship. And this will probably after a year or after some years will reflect it to the output and will enlarge and increase probably. But in the current period of time, when you are increasing the amount of the investment amount or the saving amount, will negatively affect the GDP, and it is reduced to 3,923. And for issues of policy, the key questions will be how to adjust government spending levels of tax rates so that the equilibrium level of output is the full employment level. In this case, let the economic parameters be Y is national income, T is the taxes 0.3 Y, C is the consumption 200 plus 0.9 Y minus T, and investment is 600, governmental spending is 1,000, and export is 600, and import is again 0.1 Y minus T, so-called the disposable income after the tax. Then let's go through the calculation of the equilibrium for this economical condition or level. Y is supposed to be again equal to the aggregate expenditure. When we are putting the aggregate expenditure, Y to the aggregate expenditure, we will have again 200 plus 0.9 Y minus 0.3 Y, and plus the rest 600,600 and minus 0.9 Y minus 0.3 Y. Then this will then summarize, and the result will become 5,454. As you see, it is increasing, and assumes the full employment level of output is now 6,000. What will the government spending will be necessary to reach that level? Then let's go through what will happen now. To answer this question, you are plug the 6,000 as equal to Y, put level of G as a variable and solve for G, then we are going to suppose this is then equal to the output. Then we put instead of Y now 6,000 because it is supposed to be output is 6,000 and then the full employment level is supposed to be is the output. And then we are going to equalize this equation to the other side, then 200 plus 0.9 6,000 minus 0.3 6,000 because we are putting instead of Y 6,000 now because employment level of output is 6,000 supposed for the full employment in of course, then plus 600 plus D plus G plus 600 minus 0.1 again 6,000 minus 0.3 0.3 multiplied with 6,000 which is the as I said to you, Y supposed to be. Then when you are going to solve this problem, the arithmetical answer is 1,240, which is very, very good. It is increasing, and in other words, it is increasing government spending by only 240 from its original level. Therefore, would raise output to the full employment level of GDP only required for this model 240 unit or let's say thousand or $1 billion or $1 million governmental spending or governmental expenditure. Indeed, the question of how much to increase government spending so that the equilibrium output will rise from 5,454 to 6,000 can be answered without working through the algebra, just by using the multiplier formula. Then we are using also multiplier. Here, the multiplier equation in this case is M is equal to 1 over 1 minus MPC is equal to M 1 over 1 minus R, which is the multiplier. Then the results of this to output to raise the output by 6,000 minus 5,454 will equal to 546 would require an increase in government spending of as I mentioned to you, after calculating this multiplier, gives you the similar results, which is 240, as it is from the former equation and estimation found. Therefore, if you are using the multiplier and multiply this with the 2.240, you will also get the impact to the economy, just only finding the multiplier in the equation, which is the same as the answer derived from the algebra calculation. As I said to you, the multiplier also gives you these differences without making such a longer estimation. Building the combined aggregate expenditure function. All the components of aggregate demand, consumption, investment, governmental spending, and the trade balance are now in place to build the Keynesian cost diagram in following table. Now we have table in the following slide. Table build up an aggregate expenditure function based on the numerical illustration of C, I, G, X, and M, which is consumption, investment, governmental expenditure, export, and import. The first three columns in the table are lifted from the earlier table, which shows how to bring taxes into the consumption function. And as you see here, the national income is given here 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, and 9,000. And after tax income, which is 30%, then you are going to deduce and reduce this from this. Then it will be 2,100, 2,800, 3,500, 4,200, 4,900, 5,600, and 6,300. And the consumption will be the marginal propensity of the given model is 0.8. Then you're going to multiply this with this after tax. Then you will get 2 point, of course, for the consumption we are talking about. You will get 2,280. Then you will get 2,840. 3,400, 3,960, 4,520, 5,080, and 5,640. And governmental investment exports is going to be also similarly estimated as 2,640 for the unique all, and the imports for the 10% is 300, 400 after the reduction. of the GDP. You will calculate, and the aggregate expenditure will be then 4,620. It goes like this: 5,080, 5,540, 6,000, 6,460, 6,920, and 7,318. We will also exercise this, and you will understand better. As you see, aggregate expenditure here is the C plus Q plus NX. You will calculate it. Aggregate expenditure, as you see, is more than Y, which is output, and the national income, or sorry, national net export, sorry, is the export minus import here is given. Let's go through the first column for being able to understand what we did here. The first column is the real GDP or national income, which is what appears on the horizontal axis of the income expenditure diagram is represented. The second column calculates after-tax income based on the assumption in the case the 30% of the real GDP is calculated in tax. As I mentioned to you, you're going to reduce this 3,000 30% and calculate after-tax income. And the third column is based on the marginal propensity of consumption of 8% of 0.8, so that as after-tax income rises by 700 from one row to the next, consumption rises, as you see, 2,840 will be subtracted from the 2,280, as you see here. 2,280, 2,840 will be subtracted. Then you have here 560, by which is also equal to the marginal propensity by only multiplying this 7,000 will gives you this 0.8, as you are understanding from this tax deduction. You will get this from 2,800 on the second column, subtracted from the 2,100, and you will have 700 after multiplying this with 80%, and you will get the consumption for the first, as you are understanding, isn't it? Okay, and in the previous discussion, investment was 500, government spending was only 1,300, and export was 840, and total it makes 2,640. This total is shown in the fourth column. Imports as a 0.1 of the real GDP in this example is given. Therefore, the level of imports is calculated in the fifth column, and the final column, aggregate expenditure, is the summation of the consumption, investment, governmental expenditure, and the net export, so-called the export minus import. This aggregate expenditure line is illustrated in the table. Again, here you will see I have already explained you the table, how it is going to be calculated, and it is more simple if it is given in the model as a table. You will use some numbers or numerical values for estimating the rest of the table if it is given to you in the any study or any exam. And here we are flashback again the Keynesian cross diagram. As you see, we have the 45-degree diagram where the aggregate expenditure is equal to the output, so-called the Y. The real GDP is equal at 45% to the aggregate expenditure, but as I said to you, aggregate expenditure is not always realized and not always parallelly realized or intersect always this line, but in some cases, in some studies, it has happened where this aggregate expenditure comes to the equilibrium position. We suppose then it is good for the economy. But if the potential GDP is above this, then it is problem, of course. And if it is below, it is also questionable, because you have to determine at least somehow approaching to this level where the equilibrium is desired. And as it is illustrated on the diagram, each combination of national income and aggregate expenditure after tax, consumption, governmental spending, investment, export and imports is illustrated on the graphic, and the equilibrium occurs where aggregate expenditure, as I said to you, equals to the Y, to the output, and this is occur where the aggregate expenditure schedule crosses the 45-degree line at real GDP, which is 6,000 in the model that I have done, and potential GDP in the example is unfortunately 7,000. and the equilibrium is occurring at a level of the output or real GDP below the potential GDP, which is somehow not expected, not the desired uh, estimation, let's say. And equilibrium in the Keynesian cross diagram, if output was above the equilibrium level at H, as you see, the output will become higher than aggregate expenditure at that level, and the real output is more, and it is, of course, problem. And this pattern cannot hold because it would mean that the goods are produced but piling up unsold. This means we are having surplus. If output was below the equilibrium level at L, as you see before the equilibrium or less than equilibrium, then aggregate expenditure would be greater than output. This pattern cannot hold either because it would mean that spending exceeds the number of goods being produced, only a point E, and it can be at equilibrium where output and national income and aggregate expenditure are equal. Therefore, below equilibrium, we have the scarcity, and above, we have some surpluses. Only point E can be at equilibrium where output and national income and aggregate expenditure supposed to be satisfied at the equilibrium. And the equilibrium must lie on the 45-degree diagram, as I mentioned to you, which is not always, and which is the set of points where national income and aggregate expenditure becomes equally realized. Therefore, we are always solving these problems regarding to these equations, regarding to this equity between aggregate expenditure and output, and then we will then determine whether it is less than the potential output or higher than the potential output for suggesting what to do for the government. It is less or more. If it is less, then we suggest try to do more to reach the equilibrium. If it is higher than the potential output, then we may say you have surplus, so you have to reduce your production. Therefore, you can manage and suggest when you are going to work for the government, you will do calculations and then determine and tell them what to do and how to manage their economy for maintaining sustainable economical model. If they don't do this, because usually most of the governments are not always follow up these estimations and calculations, or they may be not doing this kind of estimations, and their economy is always stagnating. And results of this stagnation, when the surplus is too much, the prices fall down, and when they have scarcity, then the price is going up. As we are exercising currently, we are in the recession. Our production becomes less and less because of the pandemic. Most of the production and the supply side of the economy is reduced during this period of pandemic, and we have now higher prices because production is becoming less and the produced goods and services are not becoming sufficiently enough for the consumers, and results of this prices going up. And when the prices, as you know, going up, the rising the general prices affecting the inflation, and when the inflation going up, it is affecting and changing the whole parameters. Inflation affects the interest rate affect the investment, because if you are increasing the interest rate, as you are observing the America in the central bank, in the Federal Reserve System, there are also heavy inflation also in the European countries, in the emerging economies, and we have some scarcities in the supply side because of this pandemic and because of this less production, and this is problem. And we are in the 2023 also recession because we are still struggling to solve these problems. And when we are finding the equilibrium on the table, then the gives some information on an economy. The Keynesian model assumes that there is some level of consumption even without income. That amount is 236 minus 216 will gives you 20, which is the autonomous consumption. And this is then will be consumed when national income is also zero. Assume taxes are 0.2 of real GDP. The marginal propensity to save of after tax income will be 0.1. The level of investment will be 70. The level of government spending will be 80, and the level of export will be 50, and imports are 0.2 after tax income. Let's go what will happen. Given these values, you need to complete following table and then answer these questions. What is the consumption function? What is the equilibrium? Why is the national income of 300 not all equilibrium? And how do expenditures and output compare at this point? We have the table now. We will fill this table. We will solve this table. For example, I may give you in the exam this question and you want to know how we are going to solve this. We have only the consumption only here, the first year. And we have the income 300, 400, 500, 600, and 700. We don't have the tax, but we have some information which is given in the problem. We have the after tax income estimation probably, and we have investment, governmental expenditure, and export and import and aggregate expenditure will be then estimated. Let's go through. Step 1, calculate the amount of the taxes for each level of national income. We are reminding GDP is equal to national income for each level of national income using the following as an example. The national income is 300. The tax is supposed to be 0.2, which is 20% multiplied with O somehow. And the tax amount is $60 supposed to be. And the next step is calculate after tax income by subtracting the tax amount from national income for each level of national income using the following as an example. National income minus taxes after tax income, so-called 300 minus 60, we will have then the tax after income or after tax income 214. We will do for all this. Calculating step 3, calculate the consumption. Marginal propensity to save is given as 0.1. This means the marginal propensity to consume is 0.9. Since marginal propensity saving plus marginal propensity to consumption is equal to 1, therefore multiplying 0.9 by the after-tax income amount, we will get, of course, the propensities and the consumption amount for the consumer. In a given example, we have 260, and the rest you will also estimate with this estimation model. And the step 4, consider why the table shows consumption of 236 in the first flow. As mentioned earlier, the Keynesian model assumes that there is some level of consumption even without income. That amount is 263 minus 216 will gives you the $620, which is autonomous consumption, as I mentioned to you. Autonomous consumption means whether you are working or studying or are you not working, is the amount of money that you have to consume, because we are requiring some money to survive, even you are working or not working. Step 5, there is now enough information to write the consumption function. The consumption function is found by figuring out the level of consumption that will happen when income comes 0. Remember that C is consumption when national income is 0 plus marginal propensity to consume after tax income, of course. Let C represent the consumption function, Y represent national income, and T represent taxes. C is equal to $20 plus 0.9 Y minus T. Therefore, the consumption function will become then $20 plus 0.9, the marginal propensity to consumption is in the bracket. $300, the disposable income will be subtracted from the taxes. Then we have the consumption as $236 in a given model. After using this consumption, we have the step 6, use the consumption function to find the consumption at level of national income. Then step 7, at investment, governmental spending, and exports for being able to find the rest. Remember that these do not change as national income changes. And step 8, find the imports which are 0.2 of after-tax income at each level of national income. For example, after-tax income is 240. Imports of this is 0.2 or 20% of Y minus T is equal to 0.2 multiplied to 240 will give you then $48 for the imports as a tax. After tax, sorry, state. And now we have these all calculations for the all. You can do step by step for each for 300, 400, 500, 600, and 700. Then you will have these results because we don't have time to do everything all step by step, but I show you the method how you are going to estimate each of this. Then you have for 300, the tax is 60, and the after tax income is 240, the consumption is 236. You know how it is calculated, and the income, sorry, investment, governmental expenditures plus X will be then 200 for all, because it is fixed. And import, it is given actually, as it is given below in the red colored. After aggregate expenditure is also given here, as you see. And only I and G and C, if you I and G and X only estimated, then you will have 200. As you see, I is 70, G is 80, and X is 50. When you are summing this together, 70 plus 80 is 150 plus 50, because 50 here is export and NX is the net export. 50 here is export and 48 here is import. Therefore, after summing this 80 and 70, you have this 150 plus 50, then you have 200 for the all I plus G plus X. And import is also calculated, as I mentioned to you in the former slide, is 48 for the 300, 64 for the 400, 80 for the 500, 96 for the 600, and 112 for the 700. And the aggregate expenditure is also estimated as it is given below. For the 300, we have the C, as it is given here, 236 will be summed to this IGX. Then you will have, sorry, IGX minus import, of course. Then you will have 338 for the 300, and the rest is also will be calculated in similar manner. Then you will have for the 400, 444, for 500, 500, or 600. Aggregate expense will be 556, and for 700 you have 612. When you are looking to this given table, you are definitely understanding that the equilibrium realized where the national income is equalized to aggregate expenditure, and it is 500. That's why I redline this. Okay, and the step 10, answer the question, what is the equilibrium? Equilibrium occurs where the aggregate expenditure is equalized to Y. And table 11.6 in the former slides shows the equilibrium occurs where national income equalized aggregate expenditure at 500. And step 11, find equilibrium mathematically, knowing that national income is equal to aggregate expenditure. It is given to you, of course. And C plus I plus G plus NX will be then $20 plus 0.9 y minus t plus 70 plus 80 plus 50 minus 0.2 y minus t. Then results of this estimation, then you will have t is 0.2, and then national income substitute to t with 0.2y. So you will put this all together and finding the y, which is 500. That shows you which is the equilibrium that I have also estimated in the table. This is then the verification of this calculation, and shows you that the aggregate expenditure will become equal at 500. And step 12, answer the question, why is national income of 300 not an equilibrium? At national income of 300, aggregate expenditure are 388. Therefore, it is not equilibrium. It is not in the equilibrium, isn't it? Therefore, in such simple questions, when it is asked to you in the exam from the table, you will definitely answer. And in table 13, answer the question, how do expenditures and output compare at this point? Aggregate expenditures cannot exceed output, because it is, as you are observing, in the long run, since there will not be enough goods to be bought. Therefore, it's supposed to be it is less. And the recessionary and inflationary gaps in the Keynesian cross diagram, if the aggregate expenditure line intersects the 45-degree line at the level of potential GDP, then the economy is in sound shape. There is no recession and unemployment is low, supposed to, but there is no guarantee that the equilibrium will occur at the potential GDP level of output. the equilibrium might be higher or lower. It depends, of course. When you are going to calculate, you will then determine. And for example, figure A illustrate a situation where the aggregate expenditure line, the 45-degree line at point 0, which is a real GDP 6,000 and which is below the potential GDP of 7,000. In this situation, the level of aggregate expenditure E0 is too low for potential GDP to reach its full employment level and unemployment will occur. The distance between an output level like E0 that is below potential GDP and the level of potential GDP is called recessionary gap. Because the equilibrium level of real GDP is so slow, firms will not wish to hire the full employment. Number of workers and unemployment will be high. As it is given in the graph here, addressing the recessionary and the inflationary gap, if the equilibrium in A, graph A, in the left side, if the equilibrium occurs at an output below potential GDP, then the recessionary gap exists. The policy solution to a recessionary gap is to shift the aggregate expenditure schedule up to aggregate expenditure O to aggregate expenditure 1. This will then helping hand for solving this problem, isn't it? Then you will have no problem, because if you shift this aggregate expenditure to the higher level, this will satisfy this potential GDP and you will then solve this problem. The recession is then overcome, isn't it? Now we come to the inflationary gap. The equilibrium occurs at an output above a potential GDP. Then an inflationary gap exists. The policy solution to an inflationary gap is to shift the aggregate expenditure schedule down from aggregate expenditure 0 to aggregate expenditure 1 on the right side of the graph. Using policies like tax increases or spending cuts, then the new equilibrium will realize at point E1. As you see, now you are going to reduce it, either increasing the taxes, or spending will be cut. This is how it is realized for managing and balancing the economy. This was the given policy implication and impact to the government after all these estimations. And the appropriate Keynesian response to an inflationary gap is shown in form a figure. The original intersection of aggregate expenditure line is aggregate expenditure 0, and the 45-degree line occurs at 8,000, which is above the level of potential GDP at 7,000. If aggregate expenditure 0 shifts down to aggregate expenditure 1 so that the new equilibrium is at equilibrium 1, then the economy will be at potential GDP without pressures for inflationary price increases. The government can achieve a downward shift in aggregate expenditure by increasing taxes on consumers or firms or by reducing government spending. The multiplier effect, the Keynesian policy prescription, has one final twist. Assume that for a certain economy, the intersection of the aggregate expenditure function and the 45-degree line is at GDP of 700, while the level of potential GDP for the economy is $800. By how much does government spending need to be increased so the economy reaches to the full employment GDP? This is a question for you. The obvious answer might seem to be 800 minus 700 will become 100. So rise the government spending $100 or $100,000 or $100 million. But the answer is incorrect. A change of, for example, $100 in government expenditure will have an effect of more than $100, because as you see, the multiplier effect is having more impact to the economy. On the equilibrium level of the real GDP, this is then the multiplier will be more than is expected. Okay. The reason is that the change in aggregate expenditure circle through the economy. Households buy from firms, firms pay workers, and suppliers, workers and suppliers buy goods and from other firms. Those firms pay their workers and suppliers and so on. In this way, the original change in the aggregate expenditure is actually spent more than once. This is called the multiplier effect, an initial increase in the spending cycle repeatedly through the economy and has a larger impact than the initial dollar amount spent. Therefore, multiplier effect has always more than the expected or planned expenditure, which is supposed to be 100 estimated. Therefore, we don't need that much. If the multiplier effect is more than this, then you have to reduce it to the lower level, and thinking that the multiplier effects will then affect and change the whole economy more than it is expected. Figure below, the multiplier effect, an original increase of government spending of $100 causes a rise in aggregate expenditure, $100, but the $100 is income to other in the economy, and after they save, pay taxes and buy imports, they spend $53 of the $100 of that $100 in the second round. In turn, that $53 is income to others. Thus, the original government spending $100 is multiplied by this cycle of spending, but the impact of each successive cycle gets smaller and smaller. Given the numbers in the example, the original government spending increases of $100 rises aggregate expenditure by $213. Therefore, the multiplier in the example is 213 will be divided to 100 is 2.30. Let's see how it is going to be. As you see below is the rounded given, the cumulative increase in aggregate expenditure from original increase of $100 in governmental spending is represented here. As you see, it is affecting and changing more than it is expected. Then the multiplier effect, when you are putting to the equation and estimating, will be then 1 over 1 minus 100, also called the given estimation. If the marginal propensity is 70, the marginal propensity to save is 30, the tax rate is 10, the marginal propensity to income is going to be 10%. The marginal propensity then will becomes 1 minus marginal propensity to save, because marginal propensity consumption to marginal propensity to save will become 1. Therefore, if it is 30, then the rest is 70. If it is 1, the rest is 90. Therefore, you know this, I think. The spending multiplier will be then estimated as 1 over 1 minus 0.7, which is going to be multiplied with the import propensity and the saving propensity. Then is going to be estimated as 1 over, after calculating this, 1 over 1 minus 0.7 minus, because this is the propensity of the marginal propensity to consume, will be subtracted from the marginal propensity to import, multiplied with the marginal propensity to consumption, will be then subtracted from the marginal propensity to import, then will gives you 1 over 0.47, which is 2.13. Therefore, calculating Keynesian policy interventions, returning to the original questions, how much should government spending by increasing to produce a total increase in the real GDP of 100, in the goal to increase aggregate demand by 100, and the multiplier, since it is estimated 2.13, then the increase in governmental spending to achieve the goal would be 100 over 2.13 will be then $47, or $47,000 must be invested or must be used for the aggregate expenditures or for the governmental expenditures or spending for increasing the economy as it is planned, not $100. And the government spending of approximately $47 when combined with the multiplier, which is 2.13. Remember, based on the specific assumption about tax saving and import rates, produced an overall increases in real GDP of $100, restoring the economy to potentially 800, as in the figure shown here. The multiplier effect in an expenditure output model is given below. The power of multiplier effect, as it is shown and calculated, is that an increase in the expenditure has a larger increase on the expenditure output model. The increase in expenditure is the vertical increase from the aggregate expenditure 0 to aggregate expenditure 1, as it is represented in the graphic. and the increase in equilibrium output shown on the horizontal axis is clearly larger. As you see, when you are considering this small increase, it is having larger effects or larger impact to the economy because you are shifting the aggregate expenditure only 47 dollar or $1,000. It was 47, yes, 47. But as you see, the impact to the vertical line, which is affecting and changing the horizontal line largely because it is flatter and it is supposed to be more elastic. As you see, as it is becoming horizontal, it becomes more elastic, and it is affecting and changing the real GDP much more than the y-axis. Therefore, only small increase on the aggregate expenditure shift and increase the real GDP more than this aggregate expenditure amount, which is estimated 47. Therefore, only $47 or $1,000 shifts in the aggregate expenditure will shift the economy from $700,000 to, or billion, this is billion, $700 billion to $800 billion, which is a considerable high impact to the economy. This was our lecture for today. I presented to you the Keynesian model. I hope it was clearly explained to you. If you don't, then you may, as I said to you, watch again by going to the YouTube channel Ergin Fikri Akalpler. Then you flashback again this video and listen and understand comprehensively by stopping and listening again and again, because this is very good explanation for you. I explain step by step this model to you, and this will be also asked to you in the exam, similar estimations. And if you are going to listen and understand, if not clear, you may come to my office also. I will explain you there also, but I think this is very clear model for you, and you will understand easily. If you have any question, please ask me. If not, then I will stop here. Do you have any question?
Yeah, Professor, just I need to know the equation and the mathematical formulas. They are understandable. They are not that much complicated. We can practice, but those graphs.
I can upload you some more examples as an assignment. Then you will do and send me. Then I will see whether you are understanding or not, and I will discuss with you. Yes, please. You want a graph or something, as I see? You want something more?
Yeah, just graphs. They are a little bit complicated for me.
Okay.
In
Because
the
this was
first,
the former week explanation. If you go to the last part of the lesson, the last week slides, you will understand better. If not, then I will refresh you once again next week. Just remind me, then I will do it once again. No problem. We
okay,
go through once again, and they will understand, I think.
okay, thanks a lot.
Is any question? Any?
No, I don't have question.
Is it clear for you also? You
Yes,
understand the
it is
model?
clear. Yes.
Okay. Okay, then as I said to you, you can go through once again by watching this, and then you will understand better. Okay, thank you for joining, and have a nice weekend. See you next week.
Thank you. Same to you.
Thank you so
Bye bye.
much.